ladies and gentlemen. I am Dr. Claudia Albers, PlanetX researcher and professional physicist. Today I would like to share with you another one of my articles from last year. I wrote it in September of last year. And it is entitled "The Brown Dwarf Appearing in SETI Images and Draining Our Sun of Energy." And it starts, "In this paper I am going to show that one of the objects draining our sun of its energy is hiding in plain sight on SETI images, and also that it fits the profile of a brown dwarf star. Figure 1 shows Hi2 Shrem-A images provided by SETI from September 15, 2008 between 2:09 and 22:09 UTC. The images show an object that seems to be parked in front of what has become known to us as the baffle. This baffle still allows light detection over it, as most of the images show a dark or white circle indicating matter emissions from the object in front of the baffle. That is indicated by red arrows. As you can see, there's a white cloud-like emission, and it's coming from the object of interest, indicated by this blue arrow. And there is matter emission to the right as well, indicated by the yellow arrow. The sun is on the right side, but off frame for all images. So the sun is over here for this image on the right. As you can see, the matter emissions continue, and they alternate between black and white. You can see it goes on. Figure 1, Hi2 Shrem images provided by SETI from September 15, 2008 at 2:09, 4:09, 6:09, and so on until 22:09. An object to the right or in front of the baffle is seen alternatively emitting black and white clouds of matter. In all images, the blue arrows point to the object of interest. The red arrows point to the matter emission from the object of interest that appears superimposed on the baffle. Here we are. This is the matter emission superimposed on the baffle. The yellow arrows point to the matter ejection from the object of interest in the direction of the sun. So here's that matter emission in the direction of the sun, which is over here to the right in that image. The purple arrows point to the heavy iron cloud that is filling the solar system as a result of the object's emission. So here we have that cloud of gas filling the solar system between this object and the sun, and obviously coming off one of these objects, and this is the only one present here, so it's probably coming from this one. The fact that light emission can be seen in front of the baffle in 2008 suggests that it is a background feature programmed to appear in all images and not a part of the spacecraft. If it was a part of the spacecraft, it would block light and particle detection in the area of the baffle's location. It seems, though, that this program feature has improved since 2008, so that in current images, the baffle seems to be blocking out light and particle detection. The object of interest in these images is the object that appears to be made of a white ring, indicated by blue arrows. And that is ejecting clouds of matter in front, yellow arrows, and behind it, red arrows. So let's look at that again. So this is the object of interest. It looks like a white disk, and the fact that it is disk shape is very important, because white dwarf stars have disk-like envelopes of ionized gas. So you'd expect a brown dwarf star, which is an evolved white dwarf star. In other words, it's a white dwarf star that has cooled down and is now only able to emit, or mainly emit, infrared radiation. The clouds of matter appear to alternate between white and black. Most of the images shown in figure 1 are 2 hours apart. This means that this object is ejecting a huge amount of matter for its size. These matter ejections are like the CMEs or coronal mass ejections that our sun ejects on a regular basis. Only stars are able to sustain this kind of ejection, which suggests that this object is a small star. The size of the CME a star is able to produce is in proportion to its size, and since the star is so much smaller than our sun, it produces smaller and yet still dramatic CMEs. Now there are 2 planets in front of the object, Earth and Jupiter. However, we need to realize that planets cannot go through the kind of CME production that we see happening here. This is reserved for stars only. Only stars are able to ionize their surfaces and atmospheres and accelerate large amounts of ions away from their surfaces. So the planets Earth and Jupiter in front of this object cannot possibly be responsible for the large amount of particles seen here being ejected from our object of interest. The purple arrows in all the images in figure 1 point to the large cloud of material that seems to be emanating from this object and filling the area of the solar system between the object and the sun in a broad diagonal line toward the bottom of the images. So let's look at that again. This is the broad diagonal line of matter. Figure 2 shows an expanded view of the object of interest and illustrates different details about it. And here's figure 2, zoomed in image of the object of interest in figure 1, showing that the main object is the white disk in the middle. This is the white disk. The black matter ejections are to the left and right of the object. Earth and Jupiter are also shown. Earth and Jupiter are about the size of the red and blue circles. So here's Earth, here's Jupiter. Earth is a lot closer to the detector, and Jupiter is in the background because it's far into the back of the solar system. Here we have black matter ejection coming off this object, and here we have another black matter ejection coming from the front. Figure 3, HI2 SHREM-A image on the left and a HI2A visible light image on the right from September 30th, 2008, showing that Jupiter, orange arrow, has moved to the right, but Earth has stayed with the object of interest, indicated by the red arrow. So here's Earth and here is Jupiter. Figure 3 shows an HI2 SHREM image on the left from September 30th, 2008. On the right of figure 3 is an HI2A visible light image from the same date. So this is the visible light image, this is the SHREM image. So this is particles detected by the SHREM detector. This is visible light. Both images show Earth and Jupiter. Jupiter has moved to the right since September 15, but Earth has maintained a position close to the object of interest. Now Jupiter moves very slowly since its orbital period is 12 years, and yet Earth, that moves much faster than Jupiter, seems to have stayed behind. This is an illusion produced by the motion of the Stereo A spacecraft, on which the SETI imaging instruments and detectors are mounted. The spacecraft is in an orbit close to the Earth's orbit and seems to have been designed to keep our object of interest in position close to the baffle. This suggests that this spacecraft was probably not mainly launched to observe the Sun, but rather to observe our object of interest and the Sun's reaction to it. The images in Figure 1 are detected by a SHREM, which stands for Standard Radiation Environment Monitor detector, which detects particles. These detectors usually detect high-energy protons and electrons, but are also able to detect heavy ions. Heavy ions are heavy atoms that have been ionized by the fact that they have lost or gained electrons. Iron is one of these elements that when ionized would be called a heavy ion. Now, how can we determine which particles are being seen from which parts of the images in Figure 1 and the left image in Figure 3? Usually this information is provided by an imaging key, where certain colors or shades were assigned to certain particles or energy. This key is not available to us, so we are going to discover this by ourselves through examining some more images. Figure 4 shows two images compiled from the SRAM detector's detection of particles in a region of the inner solar system, close to the surface of the Sun. We see two planets and what looks like a CME being ejected from the Sun on both images. We know that the Sun mainly ejects protons, and since both CMEs look mainly black, we may conclude that black is the color used to represent protons in all SRAM images. So Figure 4, two SRAM images from September 11th and September 9th, 2016 showing the inner solar system. Coronal mass ejections coming from the Sun can be perceived. Here's one, here's the other one, where the black color predominates. And we see it is mainly black. In Figure 1, our object of interest ejects black and white clouds alternatively. So we now know that the black clouds are probably protons being ejected, but what are the white clouds then? Well, we have already concluded that this object has to be a star because it is ejecting large amounts of matter in a sustained manner. So looking at similar images shows that this object continues ejecting matter for the whole month of September of 2008. But if it is a star, it must be a small star, since the mass ejections are quite a bit smaller than our suns and not nearly as bright as normal stars. This would mean that this object is a very small dwarf and so very likely to be a red or brown dwarf star. Figure 5. The two images show the same view of the inner solar system on September 11, 2016. The image on the left comes from a SRAM detector and the one on the right from a visible light imager. Now Figure 5, or in Figure 5, we see the object of interest in the left image and it is black on the sun-facing side, but white on the side facing away from the sun. The side facing away from the sun is here. This is the black side. However, in the left image in visible light from the same day, only an outline and a small and thin light blue line right in the middle of the object can be perceived. You can see the little blue line over there. The rest of the object is in complete darkness. This suggests that this object emits very little visible light and is therefore a brown dwarf star. However, we know from the left image in Figure 5 that this object is visible to the SRAM detector and is therefore emitting particles. And since we know that black represents protons, the black side facing the sun is probably emitting protons. Then the white side would be emitting other particles, and since this is a brown dwarf star, and therefore mainly made up of iron, now here I'd like to say that at this time when I wrote this article, I thought this was the only brown dwarf star in the solar system. So I deduced that it would, because of its effect on the sun and the way the sun was getting so much weaker, that it would be the strongest possible brown dwarf star we could have, which would be an iron core brown dwarf star. However, since then I have discovered so many of these objects in the solar system that I could say that it could be another type of core. It could be a carbon-oxygen core, or it could be a helium core. Either way, it is producing heavy ions. Even helium is thought of as a heavy ion. So these particles are most likely to be heavy ions. Here I thought they were ions, but they could be lighter ions. The protons that this object has gained must have come from the sun, and the little visible light that it is now able to emit is most likely also due to the absorption of protons coming from the sun, which will allow it to start a small amount of fusion reactions on its surface. Notice that there is a diagonal line across the top right corner of both images. This line is mainly white in the left SRAM image, indicating that it is made up of heavy ions. So if we look at that, here is the diagonal line of heavy ions, and here the same line, but it's dark in the visible light image. As a brown dwarf is expected to have stopped having fusion reactions once all its fuel has been converted to iron. So this would be the densest core we could have, and also the brown dwarf star we could get with the highest possible magnetic field, because the iron core greatly increases the magnetic field these kinds of objects can have. On the right visible light image, the same region is mainly dark, which means that these particles are not emitting light and are actually blocking the light from the background stars. This is evidence of the ion dust that has filled the solar system and has built up in our atmosphere, possibly creating the red sky anomaly. This is illustrated in figure 6. So figure 6 illustration indicating the object of interest with its dark outline in visible light. There it is, as well as a thin blue line in the center of the outline. Although it's not as visible here, we know it was there in a previous image. The white diagonal region in the left image indicates that it is ions. Well, it could be other ions. It could even be helium ions or alpha particles. This region is dark in the right image. So this region is dark here. And here it's white, indicating that it's heavy ions. Figure 7, illustration indicating the region on the left of the object of interest where ion-ion ejection is taking place. So here we have, well, it says ion-ion. We could say it's heavy ion emission on the left, superimposed on the baffle. And we see here that it is actually emitting light because we can see it in the visible light image. In figure 3, repeated in figure 7, the object of interest also looks dark in the right visible light image, but yet the strong mass ejection is clearly visible. Planet Earth is in front of the dark outline of the brown dwarf, but close examination reveals that indeed the outline behind Planet Earth is dark. There's the dark outline. In the image on the left, we see that at this time the ejection looks white, so the object is probably emitting heavy ions. But the ejection is so strong that the heavy ions are going to excited states and are emitting visible light photons when they decay back to their ground state. So this is the reason why light is seen emanating from this emission. In this way, the ejection becomes visible in the visible light range. This is why white light in the right image can be clearly seen to be emanating from the ejection cloud to the left of our object of interest. And this, again, is illustrated in figure 7. So we can see white light emission here. Figure 8 illustrates what the SRAM detection of the brown dwarf reveals about its makeup. It emits both heavy ions and protons. The protons it emits are probably protons that it has captured from the sun. In the 2008 image on the left, there it is, the object looked like it was surrounded by a disc-shaped heavy ion cloud or envelope. Again, remember that's very important and characteristic of brown dwarf stars, which are cooled down white dwarf stars. In 2016, the brown dwarf star has a heavy ion cloud.
Sorry guys, this is the only part where I'm going to interject. Now, everywhere that the physicist speaks of a brown dwarf star, my personal contention has always been that it's actually a white dwarf stroke neutron star. She just mentioned a disk being around this particular celestial body. That disk, as I understand it, is a secretion disk, which it has drawn from the surface atmosphere of our sun. It's really important we understand that. It's called a cataclysmic variable. So please scroll a line underneath that and look that up. Cataclysmic variable, where it shares a barycenter with our sun, simply because both of these celestial bodies are the densest objects within this trinary star system. So when she explains a brown dwarf star, my position has always remained that the brown dwarf star that she is referring to in this particular instance is in fact a white dwarf star or a neutron star, but has a companion brown dwarf star. That brown dwarf star that's a companion to this particular neutron white dwarf star, the primary star of this trinary system, that brown dwarf star is in the outer reaches of our asteroid belt. In other words, it's behind Earth, right? So what we've got in front of us is the neutron white dwarf star, parked next to our sun, hence why they're using a solar sun simulator, to occlude that star, which is parked next to our sun, otherwise we would see it and the other celestial bodies that are orbiting the white dwarf star. And then also, because it's draining the sun of its surface energy, they need to supplement and substitute that using the solar sun simulator. What we see often behind and opposite the setting of the sun is actually the brown dwarf star, which makes an appearance every now and then, and we've shared images as well as video footage of that being caught by other individuals as and when they see this phenomena occur, and we've shared that with you guys just so that we're clear on that position, because a lot can be lost. I mean, there are very, very competent researchers studying this phenomena, but every one of us, while studying this phenomena, are looking at it from their own vantage point and their point of view, and within the boundaries of our own intellect. What and that doesn't discount any of the information being shared by any one of these individuals, and nor am I saying that my position is more superior than anyone else's with regards to this particular phenomena. What I have done, and which has not been done by anyone studying this phenomena, is looked at it through the lenses of Quran and Sunnah, Quran and Hadith. Hadith are the narrations of the beloved Prophet Muhammad, sallallahu alaihi wasallam, may peace and blessings be upon him. Um, uh, are narrations made by him, and in line with what's in the Quran, my personal concern always was that there is a mention of a star with piercing brightness as it goes down. And in all of these studies and in all of the research, what we've heard is mention of a brown dwarf star, which is quite the opposite of a white piercing bright star. It's actually diametrically opposed to that. If anything, a brown dwarf star is a burnt out star, very much akin to a coal, which is maybe hot underneath, but has a surface which hardly reflects any light, and does not um, give out a light source of its own, right? Hence why you would need these infrared cameras or telescopes, as the Vatican already does, called Lucifer, at the poles, in order to see this star or this system. So just so that we're clear on that, I mean, I really did want to make sure that we understood that whilst discussing all of this. I'll let the physicist, the doctor, continue, and then I think we'll come to a close on this particular vlog.
Cloud around it. And still, but this cloud has moved to the right side of the object, or the side facing away from the sun. There it is, facing away from the sun. This is the heavy ion cloud. The side facing the sun is mainly emitting protons. This is the side facing the sun. The sun is on this side in 2016, or to the left. This is evidence to the fact that since 2008, this object has captured a lot of protons from the sun, and obviously also released a lot of its gaseous envelope. which is why it's filling up the solar system. It is due to this object's presence in the solar system that the Sun has lost a lot of its primary fuel, i.e. protons, and is growing weaker and dimmer. Figure 8, the brown dwarf star, as detected by SRAM detector in 2008 on the left, and in 2016 on the right. In conclusion, one of the brown dwarf stars draining our Sun of its energy has probably been within the solar system at least since 2008. This is Dr. Claudia Albers, PlanetX physicist. Thank you for watching. Matter. In all images, the blue arrows point to the object of interest. The red arrows point to the matter emission from the object of interest that appears superimposed on the baffle. Here we are. This is the matter emission superimposed on the baffle. The yellow arrows point to the matter ejection from the object of interest in the direction of the Sun. So here's that matter emission in the direction of the Sun, which is over here to the right in that image. The purple arrows point to the heavy iron cloud that is filling the solar system as a result of the object's emission. So here we have that cloud of gas filling the solar system between this object and the Sun, and obviously coming off one of these objects, and this is the only one present here, so it's probably coming from this one. The fact that light emission can be seen in front of the baffle in 2008 suggests that it is a background feature programmed to appear in all images and not a part of the spacecraft. If it was a part of the spacecraft, it would block light and particle detection in the area of the baffle's location. It seems, though, that this program feature has improved since 2008, so that in current images, the baffle is matter emission to the right as well, indicated by the yellow arrow. The Sun is on the right side, but off frame for all images, so the Sun is over here for this image on the right. As you can see, the matter emissions continue, and they alternate between black and white. You can see it goes on. Figure 1, HI2 SRAM images provided by SETI from September 15, 2008 at 2:09, 4:09, 6:09, and so on until 22:09. An object to the right or in front of the baffle is seen alternatively emitting black and white clouds of 15, 2008 between 2:09 and 22:09 UTC. The images show an object that seems to be parked in front of what has become known to us as the baffle. This baffle still allows light detection over it, as most of the images show a dark or white circle indicating matter emissions from the object in front of the baffle. That is indicated by red arrows. As you can see, there's a white cloud-like emission, and it's coming from the object of interest, indicated by this blue arrow. And there, ladies and gentlemen, I am Dr. Claudia Albers, PlanetX researcher and professional physicist. Today I would like to share with you another one of my articles from last year. I wrote it in September of last year. And it is entitled "The Brown Dwarf Appearing in SETI Images and Draining Our Sun of Energy." And it starts, "In this paper I am going to show that one of the objects draining our Sun of its energy is hiding in plain sight on SETI images, and also that it fits the profile of a brown dwarf star. Figure 1 shows HI2 SRAM-A images provided by SETI from September